In 1973, a biologist named Edward O. Wilson made a claim so uncomfortable it was nearly dismissed outright. He said that if ants had nuclear weapons, they would probably use them. He wasn't joking. He was warning us. Most people look at ants and see inconvenience, something you step on without thinking. But once you actually start looking at how ant colonies wage war, how they conquer, enslave, commit genocide, deploy suicide bombers, practice battlefield medicine, and eventually collapse under the weight of their own empires, something deeply unsettling crystallizes. We didn't invent any of this. We inherited it. And ants have been doing all of it for over 100 million years. Let's start with the scale, because nothing prepares you for it. Right now, there are approximately 20 quadrillion ants on Earth. Their combined biomass exceeds that of every wild mammal and bird on the planet combined. For every human alive, there are roughly 2.5 million ants. And a significant portion of them are, at this exact moment, at war. Not metaphorically. Not in the loose, poetic sense of nature documentaries. Actual organized, strategic, army-scale warfare. With front lines. With supply chains. With casualties in the millions per day. But here is what truly unsettles researchers. It isn't the scale of ant warfare that mirrors human history. It is the architecture of it. The strategy. The politics. The moral catastrophes. When you line them up side by side, the resemblance isn't loose or approximate. It is exact. Start with the army ants of Central and South America. Eciton burchellii. A single colony holds up to 700,000 individuals, and they do something no other creature on Earth does with quite the same cold efficiency. They march, columns stretching over 100 meters, moving through the forest like a living river of muscle and acid, consuming everything in their path. Insects, lizards, small birds that can't flee fast enough. They don't build permanent nests. They are the nest. At night, they form a living bivouac, hundreds of thousands of bodies interlocking legs and mandibles to create a structure with internal chambers, insulated walls, and a protected core where the queen and larvae are sheltered. Every morning, the structure dissolves and the army moves again. But what stops researchers cold isn't the marching. It's what happens when two army ant colonies collide in the forest. They don't simply fight. They negotiate. Scout ants meet at the boundary and engage in a behavior biologists describe as tournament displays, testing each other's numbers and aggression without immediate full combat. If one side is significantly larger, the smaller colony withdraws. If they are evenly matched, war erupts. The death toll can reach tens of thousands in a single engagement. And when it's over, the victorious colony doesn't just occupy the territory. It absorbs it, incorporating the dead zone into its operational range, pushing the frontier a little further with each campaign. This is not instinct running on autopilot. Researchers have documented army ant colonies adjusting raid strategies based on terrain, prey density, and previous encounters. They learn. They adapt. They update their tactics in real time. Now meet Polyergus, sometimes called the Amazon ant, though nothing about them is remotely mythological enough for that name. Polyergus colonies do not gather food. They do not tend their young. They do not build or maintain their own colonies. Their entire civilization, their entire existence, is built on one activity: raiding. They launch organized military assaults on neighboring Formica colonies, targeting specifically the pupae, the young before they hatch. These captured pupae are carried back to the Polyergus colony, where they hatch, chemically imprint on their captors as family, and spend their entire lives doing every single thing the Polyergus refuses to do. Feeding them, cleaning them, raising their young, defending the nest. The Polyergus workers, meanwhile, have evolved mandibles so specialized for combat that they are physically incapable of feeding themselves. They cannot pick up food. They cannot dig. Without their enslaved workers, they starve surrounded by resources. If you removed every enslaved ant from a Polyergus colony overnight, the colony would be dead within 2 weeks. An entire species has evolved itself into complete, irreversible dependence on forced labor. Biologists call this telosis. It predates human civilization by approximately 50 million years. But Polyergus isn't even the most disturbing chapter. There is a species called Temnothorax americanus, a slaver ant. And what makes it remarkable isn't the rating. It's what the enslaved ants eventually do in response. Researchers at the University of Mainz discovered something that stopped the field in its tracks. The enslaved Temnothorax workers, raised inside the slaver colony, chemically imprinted on captors they believed were family, will eventually begin killing the slaver colony's larvae. Quietly, without triggering detection, at a rate that, over time, suppresses the slaver population's growth and limits their capacity to raid neighboring colonies. They cannot free themselves. They cannot escape, but they sabotage, covertly, over generations. The researchers called it slave rebellion, not as metaphor, as a precise scientific description of what they were observing. The enslaved ants had evolved the counter-strategy to exploitation, and they were deploying it from inside the colony itself. When this finding was published, it didn't just fascinate the scientific community. It made people deeply uncomfortable in a way that pure biology rarely does. Then there is the question of weapons. Because ants did not stop at mandibles and numbers. They kept inventing. Trapjaw ants develop mandibles that snap shut at 145 miles per hour, the fastest recorded movement of any biological structure ever measured. When threatened, they can also strike the ground with their jaws to launch themselves into the air, a biological ejector seat. Campanota saundersi, the exploding ant of Southeast Asia, evolved a mechanism where, when cornered or grabbed by an enemy, it voluntarily ruptures its own body, spraying toxic, corrosive secretions across everything within range. It dies, but it takes the enemy with it and protects the colony it could no longer protect by living. Natural selection produced a suicide bomber. It produced it independently, without any cultural or ideological scaffolding, purely through the mathematics of survival value. Some species evolved chemical weapons that mimic alarm pheromones of rival species, triggering panic and infighting in enemy colonies before a single physical confrontation begins. They perfected psychological warfare. They weaponized confusion. In the cold biochemical logic of evolution, deception proved cheaper than combat. But the most astonishing arms race development is not a weapon. It's medicine. Matabele ants wage war almost exclusively against termite colonies. Their raids are violent, brutal, and heavily contested. Termites fight back. Soldiers lose limbs. They are injured at enormous rates. And what researchers discovered when they filmed and tracked these engagements in close detail was something that rewrote our understanding of what ants are capable of. Injured Matabele soldiers, too wounded to walk, emit a specific chemical distress signal. Their nest mates then carry them back from the battlefield. Once inside the colony, other workers spend up to 4 minutes licking the wounds of each injured soldier, applying antimicrobial compounds that neutralize infection and promote healing. Ants that received this treatment survived at a rate of over 90%. Ants that were experimentally prevented from receiving it died from their wounds most of the time. The colony evolved triage. It evolved battlefield medicine. It evolved the understanding, encoded in chemistry and behavior, that an experienced soldier saved is worth more than a replacement recruited. They arrived at this conclusion 50 million years before we built our first hospital. And then empires fall. Because they always do. The Argentine ant, Linapithema humul, formed what is now the largest supercolony ever documented on Earth. A single interconnected network of billions of individuals stretching over 6,000 kilometers across southern Europe, from Italian Riviera to the Atlantic coast of Portugal. When researchers took ants from opposite ends of this supercolony and placed them together, they did not fight. They recognized each other as kin across an entire continent. One chemical identity, one empire. But that same supercolony is simultaneously at war with Argentine ant populations in California and Japan, descended from different founding groups, bearing different chemical signatures. The same species, different identities. Genocidal conflict across 3 continents. In California, the invasion has driven dozens of native ant species to local extinction. In southern Europe, it has collapsed native ant communities that supported entire food webs going back thousands of years. The Argentine ant didn't just conquer territory. It restructured ecosystems. It deleted what came before it and replaced it with itself. And now, in certain regions, its own supercolonies are beginning to fracture. Internal chemical drift, resource depletion, and the slow accumulation of genetic divergence are introducing conflict inside colonies that were once unified. Researchers are watching in real time, an empire beginning to crack along its own seams. Wilson's nuclear weapons remark was not a dark joke. It was a precise observation about what convergent evolution reveals. The behaviors we attribute to human nature, the ones we use to explain our wars and our empires, our capacity for organized violence, and our history of exploitation, turned out not to be uniquely human at all. They are the product of pressure. The same pressure applied to any organism competing for limited resources over sufficient time. The same evolutionary logic that produced suicide bombers and slave rebellions and battlefield medicine, and the collapse of empires in creatures with brains smaller than a grain of sand also produced them in us. Ants didn't learn this from us. We didn't learn it from them. We both arrived here separately through hundreds of millions of years at exactly the same answers. That is what convergent evolution means. That under certain conditions, certain outcomes are not accidents. They are destinations. And perhaps the most unsettling scientific fact in all of this is not any single behavior. It is that the logic producing them hasn't stopped running. In ant colonies or anywhere else,